Welcome back, pre-algebra guys. I hope you're having a good week. I'm probably catching you on a Thursday if you're on track. Otherwise, whatever day of the week this is for you, hopefully you're having a great day. Hopefully you guys are hanging in there. I know it's been a long time of being home, even for a homebody and someone who's more introverted. So, hope you're doing well. Hope you're enjoying some of the math videos, even though it's still school. Hopefully it's helping a little bit. Today we're going to jump into 8.2. So this is just like the other section, 8.1, except we're just going to have variables on both sides. So just trying to add a little bit at a time here, okay? All right, so in your interactive notebook, side note, I realized I forgot to talk about this in 8.1. I talked about maybe updating your table of contents. You probably don't have the ability to do that if I'm remembering correctly, and I don't have all the information at home here, but I think your table of contents only went through chapter 7. So you obviously don't have a new one, and I'm not going to worry about giving you one right now. So just keep updating your page numbers, and we'll get to table of contents later. If we do, if not, then you know what, this year might just have to be kind of make it through math year, and you're still getting the content even if your table of contents isn't updated, okay? But please stick with your notes. I hope you have found that to be a helpful resource for you this year. Okay, so let's jump in. You should have your title right here as variables. That should say variables on both sides. Okay, so we're just going to jump into example number 1. We are going to check the first two, and I'm not going to ask you to check every single one throughout the entire chapter, but just at the beginning here. Okay, so just like before in 8.1, we combine all our like terms. You want to get rid of parentheses, and then once it's most simplified, then you can go ahead and solve. So don't forget, always get rid of your parentheses, step 1. Step 2, combine all the like terms that you can. And in this case, we're going to have variable on both sides. Kind of like having a constant on both sides. We wanted to get them together, and we're going to want to do the same thing here and get our variables on the same side, and then we can go ahead and solve. So right now, our variables have a coefficient in front of them, and remember they own the sign in front of them. So you have 7x and you have a 5x, except they are on different sides of my equal sign. Remember to draw your line down through. So I always put my variables, I shouldn't say always, most of the time I put all my variables on the left. I'm just most comfortable putting them on the left. I've learned to always put them on the left. Can you put them on the right-hand side? Sure, you definitely can. It's not wrong to put them on the other side. I find it to be easier, and so I'm always going to put them on the left. You do what's best for you, okay? All right. So if I want to get rid of this 5x here, I'm going to subtract 5x because it's a positive 5x. Which will eliminate my 5x entirely on the right-hand side. And because I do it to one side, I do it to the other. So 7x and a positive 7x and a minus 5x gives me 2x equals 16. Okay, now don't forget to isolate your variable. And really at this point, do I have my variable only on one side? Yeah, I already got it right over here. I don't have any more x's on this side. And so I can just go ahead and solve this. And now this is pretty close to, it's really just a one-step problem. It's not even as complicated as most that we've done. So that should cancel, and x equals 8. Okay, not so bad, right? Let's try example 2. So we have variables, and they happen to be on both sides again. Y'all, thanks for bearing with my handwriting. It looks terrible on here, but it's getting a little bit better, I think. Hopefully it'll get better as time goes on here. Okay, so I want to get them on itself, but let's see. If I move my x like I did before, let me see if I can find my pointer. There it is. If I move this x to the other side, if I get rid of it, I'm going to have nothing on this side. Okay, so I'm going to show you how to do this both ways, so we can have the x on this side, and we can also have it on the other side, okay? But what I'm realizing is I forgot to go and check this. So let's come back there. Sorry, I'm not being very linear right now. All right, so let's move that out of the way here so I have a little bit of space. Let's go back to our original problem, okay? 7x equals 16 plus 5x. And I know that 8 is x now. So instead of writing an x, I'm going to use 8. But I need to do that every single place I see an x, not just in one of them, okay? So every place I see an x, now I'm going to use an 8 instead, and we'll simplify it and see if the statement's true, okay? So 7 times 8 gives me 56, and now I have 16 plus 40, and that gives me 56 equals 56. Is that true? Yes, perfect. So x is equal to 8. All right, does that make sense on that first example? All right, let's jump back to the second example, sorry. So I wanted to move my x's on this left-hand side, and then I had a number on the right-hand side. Okay, I'm going to show you it the exact same way, and then I'm going to do it again over here, moving my variable to my left-hand side, and you guys can decide what you like to do best. Okay, doesn't matter. Neither one is right or wrong. There's just two different ways. It's whatever you prefer. All right. So if I did what I had done previously, I subtract 8 from x from both sides, and that eliminates it on my right-hand side. And I'm going to have it 8x minus x gives me 7x plus 5 equals, well, I don't have anything. Well, if you don't have anything, isn't x plus 0 the same thing as just regular x? Really, there's always, there's an infinite number of zeros. You can add 0 however many times you want. It won't matter. So we would just make that a 0. And then we're going to need to solve for our x, and it is currently being added to and multiplied. Remember, when we do the opposite, the reverse order of operation, we have to go backwards. So normally the order of operation says to multiply before you subtract or add, but we're undoing it, so we're going to undo our addition first. Again, I know I'm going kind of quickly over this. This should be review, and most of you have done a really great job with this. 0 minus 5 is going to be a negative 5. I can divide this by 7. Now, I know you guys don't like it to not come out evenly, but I can actually have an answer of negative 5/7. And I'm just going to leave it as a fraction. We'll check it in a minute here. I was about to ask you to remind me, but you can't remind me. Okay. Well, let's see. This is the other second way to do the exact same problem. Again, I don't really care which way you do it. I just want to show you both. You find what you think is most comfortable for you. All right. Instead of trying to move my x's over to the left-hand side, I'm going to move them to the right. And that's because I'll have a 5 left over on this side already. Okay? So I'm just going to move the x's and put them together. So I want all my x's on one side, and then I want all my constants on the other side. Just like here, I had all my x's over here, and then I had a constant. It was just some number without a letter or a variable. Same with here, right? I got my x's, I moved this one over here, so now I had just x's, and then I was left with a constant. It's the same thing, okay? So in that case, I'm going to want to get rid of this 8x, and if I do it to one side, I have to do it to the other, do the opposite. So I have 5 equals a negative 7x, because why is that a negative 7? Technically, there's a 1 there, right? A positive 1 minus 8 is negative 7. Now, I'm going to divide this by negative 7 because I'm looking for just my x, and divide the other side by negative 7. So now I get x to equal negative 5/7. Now, this looks a little bit different, but as long as there's an equal sign, x equaling negative 5/7 is the same thing as negative 5/7 equaling x. This is a form of commutative property. You could really just switch these, and you can write it this way. You can go straight from there to that. Okay, it doesn't really matter whichever one you'd like to do. Now, let's go back in and check to make sure that we have an answer that makes sense here. So let's go to the original equation. All right. And now remember, everywhere I found there to be an x, I need to use my negative 5/7. Not just one spot, every single spot. Okay, so now Technically, this is an 8 over 1, and when you're multiplying fractions, remember, just multiply the numerator across and the denominator across. That gives me negative 47ths plus 5, but I know that I want to add 5, but I can't add just a 5 over 1. When I add fractions, I have to have a common denominator. So let's come over here. 5, let's make this blue. 5 over 1 is going to be equal to some fraction equivalence with a 7 in the denominator. Well, in order to get from 1 to 7, I have to multiply by 7, so I'm going to do the same thing to the top, which gives me 35 sevenths is the same as 5. So instead of adding this 5 here, I'm just going to add 35 sevenths. Is that equal to negative 5 sevenths? Well, let's see. Now I can add these two together, and I have negative 40 plus 35. And a negative and a positive, we know we have to subtract those and keep the sign of the larger one, or the absolute value that's larger. Gives me negative 5 sevenths equals negative 5 sevenths. So good. We did it right. Okay, why don't you try the skills check on page 319. There should be 6. Please pause the video here. Your first 4, all you have to tell me, are you adding, subtracting, and what part are you adding and subtracting or multiplying and dividing in order to solve. And really, I think we're just looking for the variable, so you are only going to pick from adding and subtracting. Okay, try that for 1 through 4, and also solve and check for 5 and 6. Okay, so let's go ahead and check these answers. For number 1, you need to move your variable to be on the same side, and the best way to do this would be to get my 4 away from that 16. If I move it to the other side, I will have all variables on the left and all constants on the right. That's the step we've got to get to in order to solve. So I need to subtract, and I'm just going to abbreviate there, 4c from both sides. Okay, so for number 2, it's very similar, except right now there's a minus 2x on the right hand side. So if I want to get all my x's on the left, I need to do the opposite in order to get it over there, which means I'm going to need to add 2x. And then I'll have all my constants on one side and all my variables on the left side. Okay, now, so number 3 and number 4, it says that we want to get the variable only on the right hand side. This is the way I showed you. For example 2 right here. It's whatever I moved over to the side here when we moved our x to the right hand side. Now, I don't really like doing it this way all the time. I just like getting it on the left. I want you to know you can do either way. So I'm going to tell you the answers based on getting the variable to the right, but either way is okay. Technically, you could always put it on the left if you like it on the left. All right, so for number 3, in order to get the variables on the right, we're going to need to subtract 3n. For number 4, in order to get them on the right-hand side, we're going to need to subtract 5y because it was a positive 5y. All right, and then we'd be left with a negative 24. Be careful, your sign owns the number owns the sign in front of it, and you can't just eliminate it and get rid of it. All right, so for number 5, you put your 3x and your 5x together somehow. Whether you put it on the left or the right, you should get x equals 9. And if you plugged it back in to check, that should be confirmed. And for number 6, you should get r equals 3. If you're stuck on those, go back and watch the videos, check your work, see where you made a mistake. All right, let's keep rolling here. Okay, so we have variables on both sides and constants on both sides, so we're going to have to do a lot of rearranging. Like I said, I like to get my variables on the left, but you can do either one. Okay, in this case, there's really not a better way since you have to move some things around. So I like to move my variables first. I'm trying to get my like terms on the same sides. Okay, so I've got my green and my yellow. Remember the signs. Go with the number, the constant, or the coefficient in the variable. Okay, so I'm going to have negative 3x left over on this side. I still have my plus 9. I haven't done anything with that. Equals, this has gone away, and I'm left with a negative 3. Okay, so I'm looking to get now positive 9 and my negative 3 together. which means I have to put a negative 9 on both sides, or subtract 9. I'm left with 3x. This disappears, and then I will get a negative 12 on my right-hand side. Okay, so last step, I am looking for my x. Divide by negative 3, x equals 4. Now, if you were to check this, you would need to put in a 4 both here and here. Okay? All right, let's keep going. Let's go ahead and put my variables on both sides, my constants also on the same side. And the difference here, I just want to point out, is that when you are moving some things to both sides, make sure you keep the sign with it. Okay, so we'll go through this one a little bit quickly. It's a lot like our last one. All right, I'm going to subtract 3x from both sides so that I can get all x's on the left. So I will get 4x, 7, and a negative 3 gives me 4. And I still have this, oops, there we go, negative 5. I haven't done anything with that. This is eliminated, and 10 is on my right. Okay, now I have my x, and it's being added, and, oops, my x is being added to, with the negative subtracted from, I guess, and multiplied. Okay, so in this case, we just want to make sure we're going to add 5 to both sides. This is eliminated, 4x equals 15. Okay, now is this going to come out evenly? No, it is not. Is that okay? Yes, it is. All right. Is this in its most simplified form? Is there something that you can divide both of these by? This is really simplified. Okay, if you want to turn it into a mixed number, you can. 4 goes into 15 3 whole times with 3 of them left over. So you could say you have 3 whole and 3 fourths, but I'm fine with just 15 fourths. Now, if this was 38ths, then you would need to divide both by 2, but as long as it's simplified, just leave it as it is, okay? All right. Second to last one, almost there. If you are wanting some more steps, if you look on page 320, they are laid out 1, 2, 3, 4, 5. You can write them down. We've been going through this over and over, and I'm going to kind of talk us through that. But if you want that in your notebook, just kind of bringing that into the light. Okay, so we see parentheses, and there is more than one term inside my parentheses. That means I need to distribute. No matter what's in front of there, I'm going to need to distribute it. Even if it's a plus sign and I distribute a 1, distribute a negative. The first step you need to do is get rid of all your parentheses. Then we can simplify by putting our like terms together and go from there. Okay, so let's just write all this out. I'm going to come all the way over the side. It's going to get a little bit longer. I have 4x. And then a 4 times a negative 3 is negative 12. Set that equal to a negative 2 times a negative 3 gives me negative 6x. And a negative 2 times an 11 is negative 22. All right, I guess I overcompensated there. We'll just have to combine these now. Remember, if you want to continue to draw a line through that. All right, I'm going to add 6x to the right and to the left, so that I can get rid of my 6 on my right side. That gives me 10x minus 12 is equal to negative 22. Still looking for my x, so I need to get rid of both this minus 12 and the 10. So we're going to do the reverse order of operations. Always get rid of the adding and subtracting before you divide. All right. So I have negative 10 on this side. Now I can divide both sides by 10. This can still have a box around it. If you guys are getting away from boxes, that's okay. I know at the beginning we boxed our x every single time. If you are beginning to get comfortable without that, I'm okay with that. So x is going to equal negative 1. All right, if you were to check that, you would have to go back in, put it in for the x's, and don't forget to follow the order of operations. That means do what's in parentheses and then your exponents, and then multiply, divide from right to left, and add and subtract. Okay, here's our last one. You're doing a great job. This one, we just have to do our distribution, the distributive property. Then we're going to have terms to combine on my left side, and then I can go ahead and combine from opposite sides. Okay, so there's just kind of an extra little step there. All right, let's do this. 3x, negative 3 times an x, plus negative 3 times 4 gives me negative 12. So you could say plus a negative 12, or you can just say minus 12. Minus 8, that stays here. I didn't get rid of it. I just have to bring it down and rewrite it. Just like this side, I'm going to bring it down and rewrite it. Now over here I have some of these constants that I can put together first. So let's simplify this a little bit more before I do anything else. So that's going to be minus 20. When you have two negatives and you're putting them together, it just stays negative. Oops. 2, 4. Okay. Now I want to get my x's together here. So I am going to move them over to the left-hand side, as you know I like to do. Negative 6x minus 20 equals 4. Again, any point I'm going too fast, go ahead and just pause the video. Look over what I'm saying, back up a little bit. Okay, solving for x. I'm going to need to add my 20 to both sides. Negative 6x is equal to 24. Now I just have negative 6x equals 24, so x would equal negative 4. All right. Well, here is your last skills check. It is on page 321. Pause the video. Give these a try. Let's see how you do. All right. So for our first one, you had to get your m's on the same side and your constants on the same side. You would end up having m equals 6. For number 2, you would have to get your s's on the left side and your, I guess, either side, and your constants on the other. So you would end up having a negative 8x equals a negative s, or negative 8. So s is going to equal 1. Number 3, you had to distribute first, and then you had to combine your x's. You might have wanted to put your x's on the right-hand side if you're doing it the way the book does without having to put a 0 in. If you did it my way, you put them on the left. Either way is fine. Whatever's easier for you is really what's the easiest. X equals 10. All right, number 4, we're a few more steps. I'm just going to kind of walk you through a little bit more of this. Running out of space here. Let's see. Okay, you had to distribute first, so you should have gotten 6y plus 24 equals negative 2y. Careful here. This might have been where you made a mistake. A negative times a negative is a positive, which then would give you 8y equals, let's see. Hang on, I think this number, oh goodness, this should be a 12. Okay, this is a good reason why you don't do math late at night, guys. It's just a quick tip for you if you don't learn anything else. Okay, 3 times 4 is 12. Okay, so then we will get negative 4 on this side, divide both by 8. And y is going to equal, now again, is this simplest form? No. Can I leave it a fraction? Sure. Just make sure it's simplest form. Okay, we don't want this one. We want to simplify it to negative 1/2. All right, I hope you did well on that skills check. You are done for today. I believe tomorrow I have Friday scheduled for just like a catch-up day, and then Monday we will practice with some of this and have a little assessment, and then you will be on Easter break. Congratulations, we've made it. I don't know how much of a break it will feel, but at least you won't be doing schoolwork, so enjoy time with your family. Make sure you are loving people well, doing fun things, putting your phone away, getting off the computer and getting outside and building relationships. Remember, relationships are more important than anything else, so invest in those well and forgive a lot and give a lot of grace, because we all kind of need it as we are cooped up together. But what a great spot to just grow and learn to love each other well. So praying that over every single one of you. I know each family home situation is completely different, and so some of you are loving it, some of you are making it, some of you can't wait to get back into a rhythm of something else. But whatever place you're at, that's exactly where God has you. And so ask him how you can be a light to the people around you, and how you can learn to love him more and others more through this. So Missing you guys. Can't wait to be together soon. Have a great rest of your day.